Hello everyone, welcome to trial 3 for what our anatomy class could look like. We're going to continue taking a look at the chemistry of life. So we've examined pH and now it's time for us to take a look at enzymes. Enzymes are found in multiple different places throughout the body, and the reason that they are so beneficial is they speed up chemical reactions throughout the body, but the best part is that they don't cost the body anything. In fact, there's no need for extra energy for enzymes to do their job. Therefore, we can say that they act as a catalyst. Specific reactions, for instance, digestion, requires very specific enzymes or enzymes that aid in digestion. All enzymes do not perform the same function. However, all enzymes, regardless of what function they perform, all are going to get their reactions done under homeostatic conditions or at normal body temperature. This leads us to then the active site theory. The active site theory, similar to our idea or general understanding so far of anatomy and physiology, where we state that shape determines function. So an enzyme shape is going to allow it to perform whatever task it's meant to perform. The specific function of an enzyme is also dependent upon the shape of the reacting molecule or the molecule that it works hand in hand with to get some type of product. Those reacting molecules are known as substrates. Now, when we get the enzyme to act, we've got this 4-step process, as you can see, to get the reaction done and completed. First and foremost, enzymes and substrates have to be in the same area. So if you've got an enzyme in the stomach, it's only going to work with a substrate in the stomach. It's not going to move itself around and find a substrate in the mouth, for instance. Substrates then have to fit into the active site of the enzyme. And the active site is just the specially shaped area, and we call it the enzyme substrate complex. If you look down at that diagram at the bottom of your screen, you see that dark blue figure that kind of gives you a nice W type of top or shape up on the superior part. That would be the enzyme substrate complex. The substrate, once it is in that complex, is going to then be changed into the product. And this can happen in 2 ways. The substrate can be broken into 2, or it can be combined into 1 in order to create a new compound. As you can see again at the diagram at the bottom, we have 1 substrate coming in. Once it reaches that active site, it then becomes 2 separate products, that pink piece and the yellow piece. Enzymes, after we get this new compound, are going to release the product and remain unchanged, which means they have the ability to continue to catalyze reactions of the same type as long as there is substrate available. This nice enzyme action link we'll go ahead and we'll watch together in class, but if you needed it, it's here available to you in the slides. Now, as I mentioned, we've got lots of enzymes throughout the body. However, they like being again at homeostasis. So a couple of things affect enzymes and their functionality. First is pH, next is temperature. In fact, they're really sensitive to these things. The smallest changes in either will prevent an enzyme from getting the reactions done and creating the products the body needs. The reason being is a change in pH or a change of temperature will actually physically change the active site of the enzyme, and this process is known as denaturing the enzyme. If you take a look at your bottom of the screen, we've got like a Mr. Pac-Man enzyme under homeostatic pH conditions. Then off to the right, we've got an enzyme that has undergone some type of pH change. And remember, even just 1 unit of pH change is a 10-fold change in hydrogen. So Mrs. Pac-Man is going to do really well with substrates that fit into her active site. Whereas the enzyme that's been denatured using the same substrate is no longer going to have any type of chemical reaction possible because the 2 pieces don't fit together. If you have any questions on the material so far, please make sure you bring them back to class when we meet. Thank you.